In this video, we're going to discuss solving absolute value inequalities. So an absolute value inequality might look something like this. And the important thing to remember anytime we're dealing with absolute values is that the absolute value of a number is its distance from zero on a number line. So if we draw our number line here, if we think about where the distance from 0 would be equal to 2, if we come 2 units to the right, we're at the number 2, and if we go 2 units to the left, we're at the number -2. So when we talked about absolute value equations, we said if its absolute value of x equals 2, then x could be 2 or -2. But now we're saying something different. We're saying that the distance from 0 should be less than 2. So the numbers 2 and -2 are not going to be solutions here because their distance from 0 is equal to 2. So if we think about what kind of numbers would have a distance from 0 that's less than 2, that would be numbers like 1, for example. 1 is right here, so its distance from 0 is less than 2. In other words, it's closer to the number 0 than the number 2 is. Whereas if we looked out here at the number 3, that would not be a solution because its distance from 0 is 3, which is more than 2. So the solutions to this inequality would be the numbers that are strictly between -2 and 2. Now it would be very similar if it was a less than or equal to. We would still have the numbers between -2 and 2 as solutions because we're still including numbers whose distance from 0 is less than 2, but now we're also including numbers whose distance from 0 is equal to 2, and we already established that those numbers are 2 and -2. So the only thing that adding the or equal to part would change is that we would have closed circles instead of open circles. So if we look at what we shaded here and we think about how could we write that in as an inequality, the top graph says that x is between -2 and 2, so that would be the same as this inequality. -2 is less than x, which is less than 2. And similarly, the one at the bottom says that x is between -2 and 2, or it could be equal to one of those numbers. So this is how we're going to set up our absolute value inequalities where it's a less than or a less than or equal to. It basically turns into an and inequality. This one down here is saying -2 is less than or equal to x and x is less than or equal to 2. So bottom line, if k is a positive number, I'm going to underline positive because we're going to see an example where k is not positive and we're going to have to do something different. But as long as k is a positive number, then to solve absolute value of some expression is less than k, we're going to solve this inequality. So we haven't talked about that notation f of x yet, but that just means some expression involving x. So if we have not just x, but some expression with x inside our absolute value, and it's less than a positive number, we're going to translate it into this compound inequality down here. Now, of course, this has the absolute value by itself. So if the absolute value is not by itself already, we're going to want to fix that. So for example, if we have absolute value 2x minus 3 plus 4 is less than 6, we need to get that absolute value by itself first because the procedure we were just given had the absolute value by itself. So we're going to subtract 4 from each side. so the absolute value of 2x minus 3 is less than 2. Now, eventually when we have done less than and greater than, it's going to be important to remember which is which. So if we think about our number line, here's the number 0. We're looking for the absolute value of stuff. We don't care what's inside the absolute value right now. Just think of it as absolute value of stuff is less than 2. So that means that the distance from stuff to 0 should be less than 2. So if we label those two numbers where the distance is equal to 2, we need to think, should I be closer to 0 or farther away from 0? If we want the distance to be less than 2 units, that means we should be pretty close to 0. In other words, we should be in this interval here. So we change this to say negative 2 is less than 2x minus 3, which is less than 2. Notice how the absolute value is not there anymore. It doesn't really make a whole lot of sense to keep it there. I guess it's still a true statement, but saying that the absolute value of something is greater than a negative number isn't saying much. We already know absolute value is never negative. So what we're doing here is we're focusing on what should the stuff inside the absolute value be. And we're saying it should be between negative 2 and 2. And now we can finish solving this by doing the same thing to all three parts. And so then we'll need to divide both sides by 2. So we'll have 1/2 is less than x, which is less than 5/2. So if we graph this on a number line, got open circles, and all the solutions are between 1/2 and 5/2. So to write this in interval notation, it would be an open interval. So this process that we discussed, when we wrote it down, we said if k is a positive number. What if k is not a positive number? What if we have the absolute value of something is less than a negative number? Well, that doesn't make sense, right? If you take the absolute value of any number, it's going to be positive or 0. So it will never be less than negative 3, regardless of what you substitute for x. This statement is never going to be true. So this inequality has no solutions. So that's our procedure for if we have a less than, or if we have a less than or equal to. The procedure would be the same. It's just that then we would have closed circles on our number line, and we would have brackets on our interval notation instead of parentheses. Now what about if we have an inequality where the absolute value of something is greater than a positive number? So here's 0. We know that if the distance from 0 is equal to 2, then we're standing either at 2 or negative 2. Now what this inequality is saying is, it's saying that your distance from 0 should be greater than 2. So this time we don't want to be close to 0. For example, the number 1 is not a solution anymore because the distance from 0 is 1. That's not greater than 2. However, if we look further out, the number 3, for example, is a solution because it's 3 units from 0, which is more than 2. So the numbers way out here pass to our solutions, as well as numbers over here like negative 3. Its distance from 0 is more than 2. So the numbers less than negative 2 are solutions, and the numbers that are greater than 2 are solutions. Now the same number will not satisfy both of those inequalities, but it doesn't have to, as long as the number is either less than negative 2 or greater than 2, it will be a solution. This would be very similar if we had a greater than or equal to. We would just have filled in circles, and we would have less than or equal to and greater than or equal to symbols. So here's the moral of the story then. If k is a positive number, okay, then to solve an absolute value inequality where you have absolute value of something is greater than k, you're going to solve this compound inequality. F of x is less than negative k, or f of x is greater than positive k. So when we had absolute value less than a positive number, it turned into basically an and inequality. We just wrote it in the condensed version. If we have absolute value greater than a number, we get this compound or inequality. And again, if the if the absolute value is not by itself, then we're going to need to isolate it first, because that's how it was in what we just did. So here we would need to subtract 4 to get that absolute value by itself. Once the absolute value is by itself, then we say, all right, what am I dealing with? I'm dealing with a greater than here. So my distance from 0 on the number line should be greater than 2. So again, once you have a mix of greater than and less than problems, it's important to distinguish which is which. If your distance from 0 is greater than 2, you should be pretty far away from 0, not very close. So that's how you know you're at the ends of the number line. So the expression inside the absolute value should be either to the left of negative 2, in other words, less than negative 2, or it should be greater than positive 2. So picturing the number line really helps. If you keep in mind the absolute value is a distance from 0, that should tell you which part of the number line you're considering, and then you can set up the appropriate inequality. Also notice the absolute values are gone now. It definitely would not make sense to have absolute values for that first part, because it says it's less than negative 2. Absolute value can't be less than a negative number. We're simply considering what's inside the absolute value. So we end up with x is less than 1/2, or x is less than 5/2. I'm sorry, greater than 5/2. So if we graph that, here's 1/2. So any number less than that is a solution, and here's 5/2. Any number greater than that is a solution as well. So to write the solutions in interval notation, we would need the union of 2 separate intervals, since our solutions are not all touching on the number line. Now again, this procedure only works if we have a positive number on the other side. For example, if we had absolute value of 3x plus 2 is greater than negative 3, we don't want to just keep proceeding with what we just did, because it's not the same scenario. It's not a positive number on the right side, it's a negative number. So if you have an absolute value on one side and a negative number on the other side, you need to stop and think. Here, we're saying that the absolute value of something is greater than negative 3. So if you just cover up what's inside the absolute value there with your hand, absolute value of something is greater than negative 3. What could be inside that absolute value? It could be anything, right? Because if you take the absolute value of any number, it will always be positive or 0. So certainly it will always be greater than negative 3. So no matter what you substitute for x, this will always be a true statement. So all real numbers are solutions here. And we discussed before in a previous video to write all real numbers in interval notation. We use this interval here.